All right, so I wanted to try a little example Matlab plotting of a sinusoidal waveform. So let's say I have a waveform x of t. Let's say it's equal to 100 cosine of 2 pi 100 t plus, I don't know, let's say 45 degrees, like that. Okay, so if I look at that, a couple of things that I noticed. This guy has an amplitude of 100. All right. He has a radian frequency, or angular frequency, of 2 pi times 100. Okay, that's our radian frequency. He has a frequency in hertz of omega over 2 pi equal to 100 hertz. Okay, and so he has a period of 1 over f, or 1 over 100, so 0.01 seconds. And it looks like he has an initial phase angle of 45 degrees. Let's say I wanted to plot that in Matlab. So let's go to Matlab, and all right, I'm gonna create. Let me close this here real quick. Start fresh from Matlab. So Matlab, as I open it, I'm gonna say new script, so I can write my commands in there. All right, move this guy over here. Okay, so first thing I need to do is always make a time vector that goes with this. So the time vector, like in your homework, I say, okay, we'll make a certain number of points per period. So the first thing I'm going to do actually is define my period. So my period is 0.01 seconds. And so I'm going to make a time vector that starts at 0. And basically, I want 1,000 points in a period. So what I'm going to say is, I want my minimum increment to be t divided by 1,000. That makes sure that my time steps are 1,000th of a period. And let's say I wanted to plot 5 periods. So I end at time 5t, like that. Okay, so let's unpack what I wrote here. I said start at time 0, increment in steps of the period divided by 1,000, and end at 5 times 1 period. So that should give me 5 periods. So then I can define x. So x is 100 times cosine of 2 times pi times t, times 100 times t. Now I got to be careful in any calculator, any program that you get always defaults to assuming the argument of cosine is radians per second. So I have to convert that to radians. So the 45 degrees needs to be converted to radians. Now I know that's pi over 4, but if I didn't remember that, I would say that it's pi over 180, like that. Okay. And so then if I want to plot that, figure 1, plot t comma x. I say x label, so I'm going to label the x-axis with time in seconds. And I'm going to label the y-axis with, I don't know, I just said x, but for argument, just for sake of argument, I'll say volts, value volts. All right, I don't really have a unit, I guess. I'll do it anyway. I run that. It's going to ask me to save it. All right, so I go to my Matlab folder, 2112. We'll call this SineWave Demo. And okay, it asks this one quick thing. It asks me to change the folder. If I go to try to run this program, the program needs to be sitting in the folder that I'm currently in. So I say change folder, and it's running, and there it is. Okay, so I can see basically 5 periods of this guy pretty clearly. All right. And so I'll share with you guys this code. It's relatively easy to figure out how to make these plots. Now, if I wanted to put 2 plots on the same set of graphs, maybe that would be helpful to show as well. Let's say I also wanted to show, I don't know, let's say I wanted to show y equal to 100 times cosine 2 times pi. So same frequency. But let's say I wanted to do it with 0 phase shift. All right, so I'm going to make another graph. T, X, T, Y. Now this is going to show, what I'm saying is plot the X value versus these points. Plot the Y values versus the same points. Okay? And I'm going to put that in figure 2. I'm going to run that. And there's figure 2. Okay? So I can see from this that it looks like the blue waveform, which is X, is 45 degrees ahead of the other one. So it's leading by 45 degrees. All right? Hopefully that helps. And I'll give you guys this code as well to look at how to do that.